You can use Laplace transform to solve a third order differential equation. So here's an example. If you apply the Laplace transform using the fact that Laplace transform of e to the at is 1 over s minus a, and Laplace transform of y is denoted as y of s. That's by convention. We just call this as capital Y of s, where y is really y of t. So sometimes you will see that the formula written like this, Laplace transform of y of t is defined as capital Y of s, because Laplace transform takes a function of variable t and gives back a function of variable s. Sometimes this is more preferred. But anyways, in here, although the y and y primes and all these functions are functions of t, it's suppressed. It's not written like parentheses of t. You could have parentheses t everywhere and it should be fine, but often it's too complicated, so people don't write that way. Okay, so anyways, with this, then the Laplace transform of y prime is s times y of s minus y of 0. Laplace transform of y double prime is s squared y of s minus sy0 minus y prime of 0. And Laplace transform of y triple prime would be s cubed y of s minus s squared y0 minus sy prime 0 minus y of 0. So one of the rules that you have to remember is that the number of derivatives and the powers of s, they add up to the same number. So its power is 2, but there's no derivative. 2 plus 0 is 2. Here, s is to the power of 1, and there's one derivative. 1 plus 1 is 2. And y to the second power is 2 derivatives, and it's s to the 0th power, so 0 plus 2 is again 2. And that value should be 1 less than the number of derivatives, and the very first one should have the power same as the number of derivatives. In fact, these tell us that Laplace transform changes a derivative form into multiplication by s, so that any differential equation will be turned into just an algebraic equation. That's why Laplace transform is so convenient. Alright, so let's apply all these. And because y of 0 is 0 and y prime of 0 is 0, the only thing that gives you something that's not 0 would be only thing that gives you something else is this one. So that's 1. And therefore, when you do 8y triple prime, you get 8 times s cubed y of s, and you get minus y double prime of 0, which is 1. But otherwise, just simply y double prime would be s squared y of s. None of these terms would appear because they're all 0. And then you get minus 512 s y of s minus 4928 y of s, and then 5 times, using this formula right here with a being negative 9, you have 1 over s plus 9. Let's multiply this out and you get negative 8, which if you move to the other side will be positive 8. And this is what you get. You get s cubed y of s plus 77 s squared y of s minus 512 y of s minus 492, there's an s here, I forgot, 4928 y of s, and then plus 8 plus 5 over s plus 9. And think of 8 as 8 over 1. Let's combine this into a single fraction. And also think of the left side as the following. You can factor out the y of s and rewrite it as s cubed plus 77 s squared minus 512 s minus 4928 times y of s, and 8 times s would be 8s. 8 times 9 would be 72, and then you also have 5 all over s plus 9, right? Okay, so this is what you get. Now let's continue. Let me erase everything else except this one. Now what's important is that I need to do partial fraction expansion, and in order to do partial fraction expansion I need to factor this. So how do we do s cubed plus 77s squared? Oh, there should have been 8 here. I forgot. Sorry. I forgot this 8. Right. So how do we do partial fraction expansion? We have to factor this, and in order to factor this, we have to know how to factor this cubic polynomial. Usually it's not a simple task. You have to start plugging in values and see which one works, and then you have to use what's called the synthetic division in order to do the factorization. But the person who made this question made it easy by giving something that can be done by factor by grouping. So factor by grouping means you group the first two and you group the second two, and you separately factor as much as you can. So the first two, you have s squared as the maximum factor for both, right? And these two terms now don't share any common factors. So s squared is the largest factor, which I factored it out. And then for this one, I think this 4928 is divisible by 4 at least. So let's see, 4928 divided by 4. 12 will be 48. 12 is 3. And then 8 would be, 4 times 2 would be 8, right? And then again, 1, 2, 3, 2 can be divisible by 4. A quick way to figure out if something is divisible by 4 is by looking at the last two digits. If the last two digits are divisible by 4, then the entire thing is divisible by 4. 4 times 3 gives you 12, and then 4 doesn't go into 3, and 4 times 8 gives you 32. And this is still divisible by 4, so if I do that, 4 times 7 is 28, and then you get 28, so 77, okay? So 4 times 4 times 4, that's 64. So we know that 4928 is 64 times 77. And 512, I hope you realize that 512 is like 2 to the 9th power, so it's definitely divisible by 64. So what I want to do is I want to factor by 64 because both of these term numbers are divisible by 64. And if you, let's see, 64 is 2 to the 6th power, 512 is 2 to the 9th power, so 2 to the 3rd power, 2 times 2 to the 3rd power, 6th power gives you 2 to the, okay, so this will be 8. 8 times 64 would be 512, or you can just take some time to divide, or use a calculator. 512 divided by 64 will give you 8. And then if you divide 4928 by 64, you get 77. Oh. Okay, and I factored out the minus, so both of the minus became this minus, and this turns into plus. And finally, then these two are common. If these are not the same, then the factor by grouping fails, but now they are indeed the same, then the factor by grouping does work, and you end up with s squared minus 64. And s squared minus 64 can be factored as s plus 8 and s minus 8, because this is difference of two squares, right? So you have 8s plus 77 times s plus 8 s minus 8. Okay, so that means now this above here can be written as 8s plus 77 s plus 8 s minus 8 times y of s equals to 8s. 72 plus 5 is 77, right? 77 over s plus 9. And now this is interesting. You can divide both sides by 8s plus 77. I think that's another thing that the person who made this question did so that it's not so hard to solve. And let me again delete everything except this one. So now if you divide both sides by s plus 8 and s minus 8, this is what you get for your y of s. So if you divide by s plus 8 and s minus 8, they would belong to the right side's denominator. And you just get 1 on the top. And now in order to get yt from this, you have to do partial fraction expansion. That's why we took time to factor this. The partial fraction expansion of this would be a over s plus 8 plus b over s minus 8 plus c over s plus 9. And let me show you a quick way to find ABC. So here's what you do. You want to write down s plus 8, s minus 8, s plus 9, and I want this to equal to a over s plus 8 plus b over s minus 8 plus c over s plus 9. And we don't like fractions that much, so I'm going to multiply s plus 8, s minus 8, s plus 9 to both sides. So this thing gets multiplied to every term that you see. S plus 8, s minus 8, s plus 9, s plus 8, s minus 8, s plus 9. I'm writing this so that you can easily understand what I'm doing, but you can just skip this step and straight away write down the next line just by doing mental math. It's not that hard. So you're going to get 1, and s plus 8, s plus 8 will cancel, and you get s minus 8, s plus 9a. And then s minus 8, s minus 8 will cancel, and you get s plus 8, s plus 9b. And then s plus 9, s plus 9 will cancel, and you get s plus 8, s minus 8c. Okay, so hopefully you can just see this and go straight towards to this without having to write all this. It should be obvious if you try to imagine what's going to happen, which terms, which factors will cancel and which will survive. So this is what you have. Now, what you need to do is to take this and start plugging in various values of s. And that's because these two sides, or this equality, is equality between functions of s. In other words, they should give you the same value no matter what you plug into s. So even if I plug in s equals 8 both sides, the left side and the right side should agree. And the reason for me choosing s equal to 8 is because if I plug in 8 here, 8 minus 8 is 0, right? So this is gone. This is not gone. 8 plus 8 is 16 times 17. So you get 16 times 17 times b. And if you plug in 8 here, 8 minus 8 is 0. So that's the only thing you get. And let's see, what's 16 times 17? It's 42. So 112. And then 16. So this would be 272. So b would be 1 over 272. And do the same thing for s equals to negative 8 this time, because then this will go away. Negative 8 plus 8 is 0, so 0 times anything is 0. So these terms will go away, and you get 1 equals to negative 16 times 1 times a, so that a would be negative 1 over 16. And then finally, you can plug in s equals to negative 9, both sides. So this will go away, this will go away, and the only thing that survives is this one. It's negative 1 times negative 17, so it will be just 17 times c, so that c is equal to 1 over 17. Okay, so now what do we know? Let's move on. Here is what we know. We know that if I do partial fraction expansion of this with a over s plus a, then b over s minus a, then c over s plus 9, this thing will become a times 1 over s plus 8, but a is negative 1 over 16, right? And then this is b times 1 over s minus 8, but b is 1 over 272. And then this is c times 1 over s plus 9, and c is 1 over 17. And realizing that Laplace transform of e to the at is 1 over s minus a, the inverse transform of 1 over s minus a will be e to the at. So we know that y of t, the final answer to this will be negative 1 over 16 e to the negative 8t, and plus e to the 8t, 1 over 272 times e to the 8t, and then plus requires negative, so it's 1 over 17 times e to the negative 9t. And that's the final answer. So it's a bit challenging, but if you compare this one with what you would have gotten if you did the characteristic equation and solve and find the general solution and plug in the initial conditions and all that, you'll find that this method is actually a lot faster.